Hello. Okay, good. Yeah, I'm Francis. Good morning. Yeah. Before I go through the demo, which I think everyone is looking forward to, I would like to explain a little bit on how HPE, in fact, together with our partners, are articulating or implementing the solution and has implemented in many of the industry solutions that we have deployed in the market, like smart city, smart manufacturing, and even smart logistic point of view. So typically you have seen this, I think, from Murali and also from Silicon as well. So you can see from the edge point of view, we have a cluster, and how does it map into the actual industry solution that we are really looking at in the IoT solution point of view. So in many cases, IoT will not be just the case of AI or data, right? They are a combination of many of those components, including even the edge enablement or even the core enhancement point of view. So from here, you can see that how we are simplifying the OT framework is through the help of Shifu, I think Nisys, thanks to them, in enabling some of the drivers for the devices. As you know, in the market today, legacy devices are still in action, especially in the manufacturing environment. Nobody would accept the fact that if you go in and tell them that I'm going to throw away all your legacy devices and change into all the new advanced IoT devices in the market today. So in many cases, there will be a lot of integration need to be handled in order to get the digitalization of the data to be bring forward on the data collection point of view. Then after, it will be the edge enablement. Right? In edge enablement, there could be developed or deployed in various factors. It could be a simple gateway, like transparent point of view, where data is sent from the devices all the way back to your core or the cloud. Or it could be a transformation, data transformation, which we call a transform gateway. Right? That data will be sent to the edge, and then from the edge do certain transformation or security or encryption before it go to the cloud or the core. And finally, there are instances where AI need to be brought into the edge, where we call the intelligent edge at the same time. So in many cases, edge could go into the acceleration all the ways to how AI is doing the inferencing. And further to that, it will go into the core, which it could be the cloud, and where all the intelligence or all the diagnostics or analytics or platform will be required to perform in order for the use case to be well presented to the customer. So we are really looking at how we want to operationalize the AI, not just AI for running the model and that's it, right? So it's really an end-to-end from data collection all the way to the visualization of the dashboard and how the user is looking at it. So in other words, it means that when we are really looking at the real deployment, we look into a few stages, right? First is from OT, all the devices, how we capture those and become data. From data, we will need to understand the insights of this data. What are these data and the meaning of it and how we can leverage on the insights of those data, and eventually also from data to AI before the AI can put into operation, which will be the business outcome that we are really looking at. That is the gist of what I would say, in how the IoT industry that we have been applying to the industry of deployment that we have exercised all the while. And in many considerations, you have heard, Mulari and Silicon just now as well, that edge can be a handphone, can be your devices, all the way up to even MEC in the telco industry, right? Multi-access edge computing, where the RAN, the radio access network, is being located. So it could be we are talking about just the devices and the edge gateway, or it could be even the devices with the edge gateway together with the some core enhancement intelligence that you are building on the site that you are, depending on what are the use cases. But there could be a few consideration factors that you may need to consider. Some of them are listed here, they are not all of them, right? It depends on the use cases. So it could be the power of your computing devices, whether your AI is able to be embedded on the edge device, like your handphone, right? Today is very powerful, for example. And the storage capacity, how much data you can store, on the edge, or whether some of them you have to be processed at the core, at the cloud. For example, in the network and connectivity, the latency of the bandwidth, or how fast the data will be transferred, and how much time you allow for the latency of response for the devices to react to your command, for example. And eventually, of course, the power limitation and some of the physical limitation of the environment. So I would say this is, what we call why some of the edge scenario will vary from a handphone all the way to a Raspberry Pi, or all the way to even a server at your server room, or eventually even to a radio access network, which is, a powerful server room, for example. Okay, I will look, with that I will summarize how we really implement the industry solution that we have with many of our customers, and this is the demo that we are going to show later. Yeah, I call it a harmless one because the dog look a little bit, rugged, like a military dog. But don't worry, with the safe control of it, we will manage it properly. And in the demo, I just explain a little bit so that later when you see the demo, you understand what the team is trying to show you. I'll get our guys to come here to help to demonstrate as well. So it will be put into 4 sectors, right? Below, left bottom, will be the control of the robotic dog. On the top left will be what the camera on the dog is seeing. On the bottom right will be some of the camera mounted. You can see there's a wireless camera there. They will be mounted so that you are able to navigate the dog as the dog moves around. You know where the dog exact location is. And eventually also the some AI component, which when the dog go into the analog meter, they will be able to detect the meter, and then from there extract out the exact reading of the meter itself. So just to this is a simulation, I would say, on in some cases where you need a robotic, or machine to really go into a more hazardous environment to have meter being read out, right? Especially in the utility room for some of the utility company. So in the block diagram point of view, this is how it's being mapped, right? There are 3 cameras there, and the robotic arm with a camera already mounted on the dog, and then with the help of all the partners that we have here, right, Suze and Ashnisis, we are actually powering up the entire solution. So this will be some of the use cases, or one of the use cases that we demonstrate. So we can see that it's actually not a very complex or complicated use case or demo, but rather you can see that every component need to be in place in order for it to be a real operational environment of usage. Yeah, I think I will stop here. Not stop here. I will allow the guys to come out to bring the dog here, and then from there you can see some of the demo from here. Any question meantime while they will be coming up? Yeah.
Make the dog walk.
Yeah, we will make the dog walk. Yes. So yeah, this is Bing Hong and this is Jamie. So I think we will. Okay, now we switch to the exact screen dashboard. Okay, using his computer. So from there you will be able to see the exact video stream that what the robotic dog is actually looking at. So this is the exact the dashboard. Right? Yeah, if there's any question, because please just raise up, because otherwise we will only see the action of the robots. There will be no human interaction, because just now Silicon said, right, we will have 2 components. One is human-centric and the other one is machine-centric. Yeah, I think we can start to move. Yes. So you can see that, of course, there is no additional sensor on the robotic dog except the camera. So of course we can make it autonomous, right? If you put in the relevant sensor like radar and some of the other motion sensor, for example. And now we are doing it, in a safe environment. So we are doing it manually. Yeah, currently we have a couple of so-called control buttons here. So you can see one is turning left, turning right, moving sideways left, moving sideways right, going forward, going backwards, and the stand and sit and stand of the machine, and also the speed of the machine. Of course, we put it to the lowest speed now because of the indoor environment. Yeah, so don't mind if we create a path, because they will need to go to some hidden meter which is installed at the back. Later you will go there and see as well, that they will be able to see the analog meter. And the whole solution, you can see, it's not just about one machine, right? You can see we have 3 video stream plus 1 camera video stream, and on top of it, there are a couple of telemetry data being sent from the dog and also the command onto the dog as well. It's a bidirectional communication. So it is, because we control it manually and we are not, doing the remote control. So when many of you who used to play game, right, you use the remote control, it looks easy to control. But when controlling over a terminal without seeing the dog, but only see what the camera that you see from the dog, will be something that is not so easy. With my own experience, that is not so easy. Yes. Yeah. So there's a meter here, for example, right? So you will try to go and read the meter. Yeah, of course, depending on the resolution of the camera and also the performance of all those bandwidth, then we can adjust and improve it. That will very much depend. It will depending on how or what are the use cases that you are really working on, right? In the actual deployment. So from here, there is a meter here. Then you will take a snapshot. All this can be automated, right? Of course, currently we are doing it manually just to avoid any problem. And then from there, you can see that we have captured this screen, and then from there, you have detected the value as 30. So it will be roughly there, right? Sometimes detected as 28 point something, 29, depending on the AI, how accuracy that they are really looking at for this particular one. So this is a simple use case. Although the use case is simple, the components really need to be put in place from the data sources point of view all the way to the AI and to the presentation. Yeah, I think I'm not sure. We because of time, I think we want to speed up. You want to carry the dog here to make it faster. Otherwise, it will take them a couple of minutes for the dog to go back all the way to here, right?
Take them and show the other demo.
Yeah.
The robotic arm.
Yes.
Maybe we can.
So yeah, they move the dog away. Yeah, okay. We can go to the room. Maybe I think Ashnisis, the Shifu solution, together with Suse, they have quite an interesting solution to really do a remote operation point of view. Yeah, you still have something to show? In fact, the dog, there are some other interesting stunt that you can do, right? Just in case maybe later we can demo, but now maybe we just walk to the back and come all the way here.